The vertices of triangle ABC are A minus 9, 2k minus 8, B 6k, and C k12. Find two possible values of k if angle ABC is 90 degrees. Now it's going to be tricky to sketch a diagram because we won't know where the points, which quadrants the points lie in. So what we're going to do is we're just going to draw a very simplified diagram, what we're dealing with. Angle ABC is 90 degrees, so angle ABC is 90 degrees. Okay, so what that means is that if angle ABC is going to be 90 degrees, that means that AB is perpendicular to BC. In other words, the gradient of AB times the gradient of BC equals -1. This is the criteria, the condition for two perpendicular lines. So we're going to find an expression for the gradient of AB, find an expression for the gradient of BC, multiply them and equate it to -1 and solve for k. So the gradient of AB will be k minus 2k minus 8 over 6 minus 9, 6 plus 9. Just use your brackets here. If you do not use brackets, the entire thing will be wrong. So take care to use brackets. At the top we have k minus 2k plus 8, and then that's over 15. So we have minus k plus 8 over 15. This is the gradient of AB. The gradient of BC will be 12 minus k over k minus 6. And now we know that gradient AB times gradient BC equals -1. So minus k plus 8 over 15 times 12 minus k over k minus 6 equals -1. And now we just solve for k. So minus k plus 8 times 12 minus k equals minus 15 times k minus 6 minus 12k plus k squared plus 96 minus 8k equals minus 15k plus 90. K squared minus 20k plus 15 is minus 5k. 96 minus 90 is 6. So k squared minus 5k plus 6 equals 0. K minus 2 times k minus 3 equals 0. K equals 2 or k equals 3. Now we can, this is not required, but it would be nice if you could sketch a rough diagram to show that angle ABC is 90 degrees. A is the point minus 9. If k equals 2, we have 2 times 2 is 4 minus 8 is -4. B, for this value of k, will be 6, 2, and C will be 2, 12. And when k equals 3, A will be minus 9. 2 times 3 is 6, minus 8 is minus 2. A is the point minus 9, minus 2. B will be 6, 3, and C will be 3, 12. We can illustrate the right angle triangle ABC with both conditions when k equals 2 and when k equals 3. A is the point 0.8 and B is the point 0.86. Find point C on the y-axis such that angle ABC is 90 degrees. So the first thing we're going to do is we're going to plot these points and then draw a line segment perpendicular to AB. And on the y-axis where that line segment intersects the y-axis, that'll be point C. So angle ABC will be 90 degrees. Now, because AB is perpendicular to BC, we know gradient AB times gradient BC equals -1. Gradient AB equals 6 minus 8 over 8 minus 0, which is minus 2 over 8. Gradient AB equals minus a quarter. Therefore, gradient BC is the negative reciprocal of minus a quarter, so it will be 4. Gradient of BC is 4. We can also find an expression for the gradient of BC. B is the point 86 and C is the point 0y. So the gradient of BC will be y minus 6 over 0 minus 8. So it's y minus 6 over minus 8. Therefore, y minus 6 over minus 8 equals 4, because they both equal the gradient. They both represent the gradient of BC. Y minus 6 equals minus 32. Y equals minus 32 plus 6 minus 26. C is therefore the point 0 minus 26. The way we've drawn it here, it looks like C is the point 0 minus 14, but again, this is not an accurate diagram, right? This angle is not necessarily 90 degrees the way that I've drawn it. So it seems reasonable that your point would be 0 minus 26. 3 points have coordinates A 7, 4, B 19, 8, and C K 2, K. Find the value of the constant K for which C lies on the line passing through the points A and B. So in other words, A, B, and C are collinear points. I'll get to what that means in a bit. And find the value of the constant K for which angle CAB is 90 degrees. So two different situations. Can actually have very different values for K. So A, if A, B, and C are collinear, that means that the gradient between any pair of points will be the same. In other words, the gradient of AB equals the gradient of BC equals the gradient of AC if A, B, and C are collinear points. So we can choose any combination here. Let's start with the gradient of AB. The gradient of AB is going to be 8 minus 4 over 19 minus 7. So that's 4 over 12, which is a third. The gradient of AC will be 2k minus 4 over k minus 7. And we know that the gradient of AB equals the gradient of AC because AB and C are collinear. They lie on the same straight line. So therefore 2k minus 4 over k minus 7 equals third. We can now just cross multiply. 3 times 2k minus 4 equals k minus 7. 6k minus 12 equals k minus 7. 5k equals 5. K equals 1. So C will therefore be the point 1, 2. That wasn't required. We're just going to do that for completeness sake. We've plotted A and B. We now need to plot C such that angle CAB is 90 degrees. So that could either be, C could be up here, for example, or it could be down there. In either case, angle CAB needs to be 90 degrees. So in other words, AB will be perpendicular to AC. So the gradient of AB times the gradient of AC will be -1. We've already established the gradient of AB is a third. Therefore, the gradient of AC will be the negative reciprocal of a third, which is -3. Gradient of AC is 2k minus 4 over k minus 7. So 2k minus 4 over k minus 7 equals minus 3. 2k minus 4 equals minus 3 times k minus 7. 2k minus 4 equals minus 3k plus 21. 5k equals 25, so k equals 5. C is therefore the point 5, 10. The line x over a minus y over b equals 1, where a and b are positive constants, meets the x-axis at P and the y-axis at Q. The gradient of the line PQ is 2/5, and the length of the line PQ is 2 root 29. We're required to find the value of A and B. Okay, it's going to be difficult to draw a diagram because we don't know what A and B are. The value of A and B, and we're trying to find the value of A and B. So we're going to do this without a diagram. This function cuts the x-axis at P. That means that the x-intercept will give us point P, and the function cuts the y-axis at Q. So the y-intercept of this function is going to give us the point Q. Once we get the points P and Q, we can then work with the gradient and with the length. So we'll worry about that once we've actually established the coordinates of P and Q. So for the x-intercept, we put y equal to 0. So x over a minus 0 over b equals 1. X over a equals 1, so x equals a. That means that P is the point A, 0. And likewise, to find the y-intercept, we put x equal to 0. So 0 over a minus y over b equals 1, minus y over b equals 1, minus y equals b, y equals minus b, and q is therefore the point 0 minus b. The gradient of PQ is 2/5. Now find an expression for the gradient of PQ, which is minus b minus 0 over 0 minus a. Minus b over minus a. So the gradient of PQ equals b over a. Now we have gradient of PQ being 2/5 and an expression for the gradient of PQ b over a. So the two are clearly equal. So b over a equals 2 over 5. 5b equals 2a. A equals 5b over 2. We're also given the length of PQ is 2 root 29, so we can now establish an expression for the length of PQ. So PQ is the square root of x2 minus x1 all squared, so 0 minus a all squared plus y2 minus y1 all squared minus b minus 0 all squared. PQ is 2 root 29, and that equals the square root of a squared plus b squared. Now we square both sides to remove the square brackets. So the square of 2 is 4. The square of root 29 is 29. And the square of root a squared plus b squared is a squared plus b squared. So a squared plus b squared is 4 times 29, which is 116. So we have the second equation relating a to b. In the first equation, a equals 5b over 2. So now we can just substitute this expression for a into the second expression. So 5b over 2 all squared plus b squared equals 116. 25b squared over 4 plus b squared equals 116. 25b squared plus 4b squared 164. 29b squared equals 464. Therefore b squared equals 16. Therefore b equals 4. B squared is a quadratic, and ordinarily b with b equal to plus or minus 4, but they did say that a and b are positive constants. So therefore, b equals 4. A equals 5b over 2. That's 5 times 4 over 2. Therefore, a equals 20 over 2, which is 10. So a is 10 and b is 4.